So this video is walking you through the Unit 3 project, data collection and analysis. Above on the handout there's a few ideas. You don't have to adhere to these ideas, it's just things that students have done in the past. So you're going to collect data, two variables, and for each variable you're going to construct a histogram or a box plot, or box plot. Find the mean, median, mode, standard deviation, explain in context, identify any outliers within each set. So the outlier part of it, at least in that regard, probably your best bet would be to go for a box plot so that you don't have to do any additional computations. Right? So I'd be leaning towards this. The issue is Excel doesn't really handle box plots very well. Or Google Sheets, which is what I'm going to use, but it does handle histograms very well. All right, so if you come up with a good enough looking histogram, you can probably get a good sense of where your outliers are. But I'm going to do the computations just so you have it. All right. Then once you do that, you're going to find a relationship or see if there's a relationship between your two variables. So construct a scatter plot, find any outliers or influential points, correlation coefficient, and a curve that best fits the data. All right, so you might start with a line and then just kind of go from there. And then conclusions you can draw about the relationships within and between the two variables, evidence to support your answer, which means, drawing on all this stuff. What did you notice? And then say your response must be at least 200 words. It's not really a hard and fast rule. It's just, like basically saying that it should be a substantial conclusion, not just a one-liner. All right, so let me open Google Sheets. I have a data set here. Mean, median, mode, standard deviation. I like to pair the mean and standard deviation with each other. For the mean, we do equals average. It actually gives you a suggestion for what you might want to find the average for. This actually happens to be correct. So I wouldn't need to highlight, but let's say I didn't really believe that was correct. I could highlight my actual data and then lock it in, and now I have the mean. The standard deviation, start typing equals standard deviation. You'll see that there are a few different options. We want this, it says standard deviation pretty much for all of them in some capacity. Standard error, standard deviation of the sample, text is 0. So like if you have, you put a data point in there where you say no answer or something like that, it'll treat that as 0. Population, I want the standard deviation for a sample. The .s stands for sample. All right, so highlight the information, the relevant information, close it up, lock it in. The median, start typing the thing that you're looking for, and odds are you're going to find it. The exception being the mean, because for whatever reason they don't use mean, they use average. All right, but you could see it starts giving you some suggestions. So median, highlight the column, unless you're comfortable with their suggestion, which so far has been correct, and the mode. All right, most commonly occurring values in the set, most commonly occurring value in the set, and this is the same as mode and mode single. Now, if you suspect that there's multiple modes, you might want to go with this one. All right. It says NA not because you did anything wrong, but because there was no mode. All right. Now, what I can do here is take all this information. I got to go around that little error message, but you see that little dot there? I'm going to take that and slide it over. Oops. Accidentally hit a key there. And so this is finding the average between C2 and C11. If you click on the orange here, it'll show you what it's referencing. Right? As long as it says C2 to C11, we're in good shape. Graphs. So the first one I want is a histogram for time. So insert chart. This is what it suggested. This is not what I want. So I'm going to go down to the one that looks like a histogram, and if I hover over it, it'll say histogram chart. That's the one. In terms of the scale, I'm not in love with that, and there's a lot of things I'm not in love with here. So under histogram, instead of auto, I'm going to make it 1, so it goes by 1 unit increments. You can make it go by, oh, sorry, I hit that wrong thing there. 5s, 2s. You can go back to auto. 0.5, if that makes more sense. Whatever you think, as long as it produces the correct histogram or a correct histogram. Chart title, get rid of that. We generally don't need that. Horizontal axis title, that's what should be time. Vertical axis title should be frequency. All right. I usually highlight the labels, just only for the benefit of, well, not even benefit, just the idea that maybe it'll accidentally label my graph correctly. I say accidentally because I very rarely achieve success in having sheets label it the way I want it to be labeled. If you want to change something, you can click on the 3 dots, edit chart, brings you back to the same list. And I kind of realized belatedly that maybe I do want a chart title, because I have to distinguish this from the other graphs. So I'm going to say that this is a histogram for time. Just kind of make it clear what it is. And font size and things like that. I mean, if you want to center it, you can do that too. All right, so I get rid of that, move it over. I'm going to shrink it down a little because I got to get a bunch more things on this page. So I'll just kind of put it there. I'm going to do the same thing now for temperature. Since I know it's not going to do my labels the way I want, I'm just going to highlight the data. Insert chat. Again, it assumes that I want something that I don't want. All right. Looking at these data points, I'm seeing I got a lot of negative space here. So I'm going to go to histogram. In terms of the bucket size, I don't know, maybe 1s are fine, but I'm going to go by 0.5s. All right. Axis title, chart title, we're going to say histogram for temperature. The vertical, horizontal axis is going to just be temperature. And the vertical axis title will be frequency. Now going back to that idea of having negative space, this null space here that I don't want, I can go to horizontal axis and it asks me for a minimum value. I'm going to put it in as 96.5, and it's going to do a nice job, well, reasonably nice job of centering it. You can also play around with the colors of your graphs, so that's more of an aesthetic thing. I leave that up to you. Right, but now I have histogram for temperature. One's centered and one isn't, so it's not anything I'm going to lose sleep over, but kind of like a little consistency. Right. So those are the histograms. Now just going back to the assignment. Mean, median, mode, standard deviation, explain it in context, so that's up to you. You would explain what those things mean. Now if this is time to run a mile and human body temperature, then we would say the average time to run a mile is this, the most frequent value is that, and so on. Outliers we have to address. All right. So for the outliers, I need, well, first direct observation. I'm looking at the graph. I don't see any points that are outside of the overall pattern of the distribution, right? But one thing that you could do, I mean, we're in Excel here, Google Sheets, but we could also incorporate the NumWorks, type the data in there, and see what that gives us. I mean, you got a bunch of different options. Either way, you're gonna either observe the graph, do the computations. Either way, you're going to determine that there are no outliers here. All right. So if you want to do the computations, you can. We don't really need to bother doing that by hand. You could just use technology. Either way, it's going to show. And if you refer to the corresponding video, Unit 3 project example, NumWorks, I walk you through how to find outliers there. But here I'm just going to say no outliers. So it just needs to be addressed. So then next up, just going back to the assignment, scatter plot, identify any outliers or influential points, correlation coefficient, curve that best fits the data. All right. It's all going to pretty much start and end with the scatter plot. So let me highlight both columns of data. So when I say draw conclusions within and between the two data sets, within is when we just look at time, just look at temperature. Between is when we compare the two. Scatter plot, all right, just to identify the correlation, the curve of best fit, and so on. So I'm going to highlight all my information, insert chart. When it does something like this, it's really kind of frustrating. I'm not 100% sure why this happens the way it does, but when I go down to scatter, it brings up this kind of graph, which is two disconnected sets of data, which is not what I want. All right, but I found that if I just copy and paste a data set somewhere else, so I'm just going to move over here, then run the process, it's still going to give me the wrong graph, but now when I go to scatter chart, scatter plot, it gives me the correct graph, right? Plotting the times against the temperatures. I'm not 100% sure why that is the way it is. It might have something to do with the fact that I've already made two separate graphs. So Google Sheets thinks that I always want to make two separate graphs. It's kind of weird with Excel and Sheets. It's like you do something and the software assumes that you always want to do that something, which is not reasonable. All right, customize chart and axis titles. Axis titles look pretty much the way I want. This is not a histogram of temperature, so I'm going to get rid of that. I'm going to say time versus temperature. All right. I'll center it because that's what I was doing with all of them. Probably should have stayed with the default on that because now I have to change the positioning for every one of the graphs I make just for consistency. All right, now I want it to give me the regression. All right, so I resized, I moved it just for aesthetics, but back into edit chart, under customize, a couple things. One, I'm not in love with the positioning within the graph. I mean, it's all hovering around 100. I got a lot of null space here. So I'm going to go to vertical axis and make the minimum value. Oh, looking at the data set, it's human temperature, so I wouldn't expect it to be anything less than like 90. I'll say 95. So that gives us a little bit of a better look. Maybe you even want to go higher, maybe like 96. All right. You could play around with that as long as you have all of the data points on the screen in a reasonable way. It's going to be fine. All right. Now, if we go to series, you see an option for error bars. All right. That has to do with deviation. Not something we're concerned with. Data labels, if you want. Right. That's kind of a fun add-on. And trend line. All right. So the trend line here, I'm looking at something that's linear, and I'm like, I don't know if that's really that great of a fit. Right? So I might change that to something that I think is a better fit. All right? But under label, I want to use equation. So it actually gives me the line of best fit, and I also want it to show the R-squared value. All right? That's the strength of the relationship. Well, it's actually the coefficient of determination, which talks about the percent of variation in one variable that could be explained by variation of in the other. So as one variable changes, this gives us a sense of how the other variable changes. All right. Now, linear doesn't look like it's a good option. 0.791 as an R-squared value corresponds to 0.889 as a correlation coefficient. Right? So maybe that's good enough, maybe it's not. Maybe the context makes you think that it's probably, not linear. So let me try exponential, 0.789. Just going back to linear, 0.789 is not as good as 0.791. So I'm not, and I'm not really seeing an appreciable difference in the function or the model. So I'm going to move on. I'll come back to polynomial. I'll try logarithmic. 0.736 is just getting worse. power series, moving average. I mean, that's, it's not going to give you a regression model, so we don't want that. But go back to polynomial. Degree 2 is quadratic. And again, the label we want to be use equation and show r squared. So my r squared value here is very, very good, right? 0.903. That corresponds to an r value of about 0.95. So this looks like it's the winner, right? So this is what I would go with, and I have my equation there. I'm not seeing any points that are far away vertically or horizontally, so there would be no outliers. Make a note of that. So previously we were talking about outliers within each data set. This is outliers between each data set. All right, go back to my document here. Let's see. Outlier, if there's no outliers, there's no influential points. We got the scatter plot, correlation coefficient. I should put that down. And the curve that best fits, we already got that. We got to use it to make a prediction though. All right, so the correlation coefficient that is going to be, that's the square root of that 0.903. Use the square root command, or you could just type it in after doing computation in the calculator. So this is a strong correlation between time and temperature. All right, to make a prediction, I'm going to use the actual function. So I'm going to say predict the temperature for a person who runs a mile in 4 minutes, for example. All right, so that's going to be equal to, I'm just going to follow the model here, 95.4 plus 1.03 times the x value that I just decided on is 4 plus a negative, so minus 0.0, whoop, what did I just hit? I must have hit enter. Try that again. 0.0718 times x squared, so 4 squared. I could just put a 16 there, but I could also do 4 caret 2. All right, so this is the temperature in degrees Fahrenheit. I believe I spelled that correctly. All right, so 98.3712 degrees Fahrenheit. And that's what the temperature of a person who runs a mile in 4 minutes should be. All right, so seems to be a lower body temperature. So, just going back to the assignment, we did the scatter plot, found outliers, whether they existed or not, correlation coefficient, we explained in context, curve that best fits, we made the prediction. The curve itself that best fits is displayed in the scatter plot, so we're good there. So then the only thing that would be left is to write a conclusion that describes the relationships within and between the two variables, all right? And so that part is really up to you. So you have to look at all the data that we compiled here and use that to draw some kind of conclusion. All right, and that conclusion should be substantial, referencing the summary statistics, like the mean time it takes to run a mile is this, the standard deviation is that, the correlation is that, things like that. All right, but it's really more open-ended, so I leave that part up to you.